Hi, my name is Ping. I'm on the crisis response team at Google, and I'd like to share an idea with you today. This idea is very much in progress, so if you're excited about it, which I'm hoping you will be, I'd like to invite your help developing it. Let me start by talking about the problem. In Haiti, we had many different groups that were trying to collect and verify information. The US Southern Command was surveying building damage caused by the earthquake. The Pan American Health Organization wanted to know which hospitals were still open. UN OCHA was tracking all the relief organizations that were there and where they were operating. And they were all sharing this information, largely, by emailing each other spreadsheets. Sometimes, instead of email, they might upload files to a web server, and then other people would download those files from the website. Sometimes, instead of a spreadsheet, it was a table of data that was embedded in a PDF or an HTML document, and then other people would have to copy and paste that data out of the document. What I'm starting to learn is that relief workers spend quite a bit of time working with spreadsheets, copying data from one spreadsheet to another, merging rows together, selecting columns, essentially doing a lot of database operations by hand. This, of course, seems terribly inefficient and not really a great fit for rapidly changing crisis information. What if you could get data aggregated from multiple sources automatically merged together? And what if, when that data changed in the original source, you would get updates in the filtered or merged versions of the data within seconds? What's the simplest thing that could possibly work? Well, most of this data is in tables, spreadsheet tables or database tables. So let's suppose that I have a table, and every time I add a row or delete a row or change something in that table, I'm going to broadcast that change so that other people can pick it up. And that's the core of the idea, publishing a stream of updates about a table. Now, in order for this to work, we have to assume that everyone is using the same identifier to talk about a particular row in the table. So let's suppose the rows have common identifiers. Let's call that the subject of the row. And because we're collecting data from multiple sources, the users of that data are going to want to know where it came from. So every change also needs to be tagged with the author of the change. The data might be collected offline, or it might be arbitrarily delayed in transit, so we can't assume that the change is going to arrive in order. So that means every change also needs to be tagged with an effective time. So what changed, who changed it, and when was it changed? Those are the three things we need in order to automatically merge data together. So let's talk about a specific example. Suppose we're collecting data about hospitals from 3 different sources. The US Army is surveying the roads, perhaps once every couple weeks, and they know which hospitals are accessible by road. The Red Cross, for example, is checking on the hospitals to see how many beds they have available. And there's a doctor who knows everything about the hospital that she works at, and she happens to know that the road was washed out just a couple days ago, even though it was surveyed by the Army over a week ago. Using the timestamps and authors, we can merge all these rows together and all these columns together to produce a complete picture of all the information. Now imagine if multiple people could subscribe to this. So I might have a spreadsheet that I might want to keep up to date. Maybe you have an Ushahidi instance you want to keep up to date. Maybe someone's running frontline and wants to send a text message every time a hospital is out of beds. If all the parties participate by using a protocol like PubSub-Hubbub, they can all receive notification every time a change goes out. So all the components are peers. Anybody can publish a stream of changes. Anybody can subscribe to a stream of changes. From a code perspective, this just looks like a feed of atom entries in a common format. So I was thinking of something a bit like this, with an element for the subject, an element for the author, an element for the effective time, and then the new values of all the changed fields. From a user perspective, this is what it might look like. So on top is Resource Finder, a hospital tracking application, and it's publishing all of its edits on an outgoing feed. Suppose that I add 5 available beds to one of these hospitals. When I save that entry, Resource Finder publishes the entry on its feed and notifies the hub. On the bottom is a Google spreadsheet that's subscribed to that same feed. The hub picks up the entry from Resource Finder and knows the list of subscribers, so it pushes the entry to all the subscribers, including the spreadsheet, which then updates the appropriate row directly in the sheet. You could imagine any number of other applications like Ushahidi or Sahana also picking up a broadcast like this. So that's the basic idea. It's a table broadcasting its changes, or for short, a tablecast, consisting of a stream of changes from a table where the data just consists of plain rows and columns. Each change has a timestamp, each change has an author, and all the changes are transmitted over pub/sub/pub/up. I'm really excited about the concept of getting our applications to share data in near real time using a common protocol. If you're excited about this too, please come talk to me. There are still a lot of open questions, and I'd like to get together a working group to develop this into a common protocol. Let's design something that works for everyone. Thanks.